Today is really one of the wild days. One sensation follows the other. Now we have one of our own colleagues who's been engaged deeply in the organization of this year's Privacy Week. And Philip Schaumann, welcome. Thank you for taking your time. Philip, I don't have to say it, but one might not see it, but you're a veteran. You have 50 years of computer experience. It's not a joke. No, it's not a joke. It's quite incredible. How old are you? Yeah, I'm 70, yeah. As one can see, everybody who thinks, people like up beyond 50, like me, have no idea on IT. Philip is the best example that is not true. He was deeply engaged in the training and in writing the tutorials for our speakers and for our angels. He helped most of the speakers to get their machines up and running, and really great, really great. Thank you very much. Now we're talking about problematic algorithms and how do they reach into our lives. I'm looking forward to your talk. So here we go. Philip, your stage. Thank you very much. Thank you for the chance of presenting my here. The two presenters in front of before me, we're talking about the GDPR, but we'll come to GDPR as well, you see, or something like that. We're talking about algorithms. Well, I run a website, I run a blog, and I'm part of the Kai's Computer Club family. The question is, who's using algorithm? Especially algorithms help get use speed. For instance, in high-speed trading, but also weapon systems, very sadly, who can react a lot quicker than, and we won't get rid of them because autonomous drones can only be fought by more autonomous drones, and then we got them. Yeah, algorithms always help save or replace working people. And algorithms are also used where you need additional information. It might be that this information is not necessary or not true. For instance, when you act or judge people using algorithm, it would be nice where everywhere where people are concerned and their personal lives, and it would be nice if they would be fault-free, because if you do work into people's lives, faults and errors lead to injustice, and some of them are even systematic. This is an example, not so much about algorithms that judge people, but deep learning, using big data. It used, you see in the above upper line, traffic signs, excuse me, and some of the traffic signs have been have sprayed them, and suddenly the individual driving if such systems are used to drive cars, that can be quite dangerous. And if such systems are used to judge for judgments on people, they might be just as predictive policing, for instance. Let's go back 2013. There's a computer that looks what you've been doing and all your felonies, and he sends the policeman to places where he works with a formula.
And the people who use such a program then say, oh, we found something. And the problem is that people that do not adhere to the laws then have this kind of self-confirmation because it's only there that I check whether people adhere to the law. If in another point the computer says, oh, nothing can happen here, then you will not be searched for weapons and none will be found. And the system then says, it works, great. So this is a self-confirming system. And implicitly, this is ingrained in these systems. Another aspect, there is a system in the US, the website is mentioned, all the examples I have here are in the PDF version, which you can get by going to my talk in the PrivacyWeek schedule. There's a link to that there. Now, on this website, there is a judge might supply someone's life history, someone accused in a court case, and the computer then decides whether they will get a suspended sentence or whether they have to go into prison. And then Barack Obama became president at some point and then suggested that a study should be made. And this study in 2016 found that the same identical story, the same offense committed by a black or a white person will lead to prison in the one case and to a suspended sentence in the other. And Obama didn't like that, and there was a debate, and I linked a German different study that found that the prediction quality is between 60 and 70%. But this is fixed in the algorithm. For the same deed, a black person will be punished harder than someone else. This kind of thing is prohibited, it's forbidden in Europe, but the article mentions something called Kasse Hamburg, which is probably a health insurer or something, uses this kind of system to detect fraud, and such systems are also used for tax declarations, finding tax fraud. And the same thing happens as with predictive policing. Where I search, I will find. So the prejudice that a system like that has keeps being reinforced. And you could say, well, that's not bad. We will simply take out the factors of race, sex, age, religion, but that's not enough, because in the data elements, you will also find where someone lives, which district in Vienna. That implicitly gives you some information about whether this is someone more privileged, or whether they are probably some immigrant or something. And that's what you find in the US just as much as with us. And in the US, it's quite clear. You can quite clearly find someone's ethnicity or sexual orientation. Amazon tried to use such an algorithm and to find injustices regarding their hiring. And when they used this algorithm, they found that this algorithm would select no more women than usual because they were trained with the very same decisions. So the algorithm simply took the practices that existed and continued them, and that's when they stopped using the algorithm. Because the training data that they have are so much biased to hiring men, that cannot work. A huge problem, therefore, if the training data has such a problem. Job applications, very interesting for young people. It used to be the case that the decisions were quite arbitrary, the choices. These days, it's all very objective. It uses algorithms, and there are very interesting effects. For example, there are researchers that say, allegedly, there is a 70% probability that someone's tweets will reveal whether they have a psychological disorder. Interesting. So, of course, everyone that is marked by the algorithm as having a problem will have a hard time getting a job, and you have no way of dealing with this. So with a certain probability, when you hear that with a certain probability someone can perhaps detect a depression, that's enough. Right. Telecommunications metadata even reveal more about someone's mental condition. So if you keep calling someone and you're not being called back or no one picks up the phone, effects like that. So the whole psychology of someone is embedded in their telecommunications metadata, but there's even simpler things. When they say they're not using any AI at all, there are programs, I've named examples, that simply evaluate the frequency of certain keywords. I've taken some arbitrary English examples. So if you keep writing these keywords, and there are instructions, guidelines to tell you what keywords you are supposed to use in order to trick these algorithms. That's fun to read, but ultimately this is judging people through algorithms, and that is a problem. Even if I can trick them, that is still a problem. So personality analysis. There are studies that say that the programmers, people that love certain manga comics, there are all kinds of things. So you can find that someone is represented somehow, but it's their virtual representation that is judged. So you may hear from someone, well, you may perhaps better take a prepaid plan for our mobile phones, and that's what the computer says. And they don't even offer you anything else.
Terrorism risk, for instance. Well, China goes a lot further even. In the US, such a system has been used for the no-fly list. And at a given moment, the 1.3 million US American citizens were under.
And this was stopped in the US because it simply doesn't make any sense to put 1.3 million people under suspicion.
And there's all these people cannot use a job where they have to use an airplane, and that's pretty much intrusive to your personal life, especially in the USS. now you go to the job center, my last example. As far as I'm known, now it's forbidden, but they used to split up those looking for work with a high, middle, and low chance of. A is the easy ones, B are the ones that are doable, and the last group is those that will probably never find a decent job again. And the decision, where do they spend the money for further training, will be the middle group, because that'll have the most effect. The idea is save money and be effective. Use the second link. And of course, it makes sense to invest further training in those that will get a job and pay taxes again and be employed again. Going to the PDF, there's a load of more examples. Women are treated differently as men. When somebody has obligations to look after, caring obligations, that's usually against women, because the algorithm says that usually women are the ones that care. I mean, the algorithm is not wrong. It just discriminates. It reproduces the discriminations that we have been using in our own into the software that has been forbidden at the moment. There's a new law in the works. You call that mass washing. You go and blame the computer or the algorithm, and it's not you. And the papers say, oh, the decision of the computer is only a hint. But if you decide, if the guy who is in charge decides against the hint of the computer, he has to explain it. And if he just accepts the computer's decision, he doesn't have to work at all, because he signs it and that's it. And one side is hiding behind the algorithm, and the other one is whitewashing. That's like Google says, we're just a platform, or Facebook. It's not a targeted advertising, for instance. Has weird effects. People that eat, compulsive eaters, get diet but that they look at more at dialectical websites, and but the algorithm is objective and it just looks at facts. And now that brings me to the last part of my talk. There's a beautiful publication by Katharina Zweig. There's the link. You can look at it in detail. How do faults and prejudices enter these algorithms? First phase, we have to write an algorithm. You make faults. That's pretty harmless, because those faults are usually findable. Phase 2 is where the faults become much more interesting. That's where you check and decide which data you use and which methods you're going to use. And the decision is
And you have training data, and with training data, the case is garbage in, garbage out, as we have seen with Amazon, that had prejudice in their data,
So-
and that led to the algorithm not choosing any women. The algorithm simply continued reality into the new reality, and now we come to what we call the operationalization, because if we have something abstract such as credits, score, terrorism, threats, or re-offending probabilities, these data do not exist, so we have to use other data. So which variables do you use? Well, you use the variables that you happen to have. And what you typically have of people is sex, age, those data that are easy to collect, which of course is a bit of an injustice to people, but you use the data that you happen to have because you cannot use data that you don't have. So in that respect, we have this wonderful algorithm from the employment agency, depending on residence and age and sex and elementary things like that. So it's not really the person that is being judged. More or less unusable, pointless data are being judged. And the next thing is about the records that you have. They always have an embedded bias. For example, if records are collected in European society through some kind of health investigation, that is all good and nice, but these values are often just not applicable to other ethnicities. And if you have an algorithm like that and feed it with data that does not match the target group, which I find again and again, and many of us may have heard of these things, face recognition has a huge problem with dark faces, dark-skinned faces. These have been developed for white faces and tested on white faces, and that works pretty well, but not with dark-skinned faces, which is an automatic effect. I do my tests with a certain group, and all the bias is then embedded in there. And if you have the algorithm and the records that contain all that bias, then a decision system is built and all is put together, and then you have to decide somehow how many false positives and how many false negatives would you want to tolerate. And that is a political decision, which is about saving money. Now, back to the employment agencies and their algorithms. The size of the group B that is allowed to receive a certain training, that's not decided by the algorithm. The size is decided by politics. When they say we have this training program and we will give this amount of money to that. So please make the group as large as we can pay for. That's the kind of operationalization. Now, the program is told that no more than 30% of the group can be allowed to be in this group B that is given this training. Otherwise, it doesn't work out. So the decision is not really about whether someone is getting a training. It's not really just made by the computer. It is partly just predetermined by politics, by policy. So from the start, it has been determined that the group that is allowed to enter a certain training is a certain size. That is not an algorithmic decision. It is embedded because a certain percentage of people that may benefit from that training too is not given that training because money has to be saved. So politics, especially in administrations, is setting the framework and setting the guidelines, how much financial grants exist, how much training, how much credits. That is nothing to do with algorithms, that is policy, but we are always debating the algorithms used by the employment agency. But independent of the algorithm, the size of the group is a political decision. And then we also have a phase 5, which is evaluation good if it happens, because yes, it would be nice if we evaluate. But now comes the turn to data protection, because the German parliament instigated a data ethics commission, and this had a good representation from Austrian scientists as well. I think they actually do the reporting in Parliament as well. So this is a system, evaluation system for the use, a regulation system for the use of algorithmic systems, and it's about a data ethics, creating an ethics in data and algorithms. So what these people said, we have 5 applications. Step 1 is harmless. Step 5 or grade 5 is completely prohibited. And we'll get to the next slide soon. The aim is a European regulation for these systems that was supposed to be made this year, would have done if COVID hadn't happened. Ms. von der Leyen, in her program said that in this year, an EU regulation for algorithmic systems was supposed to have been made. That is the equivalent of data protection for algorithmic systems. Then Corona happened, and I hope that next year we will have this. Now, what the Commission said is, on top we have a grade 5, which has to be prohibited, and then we have harmless grade, which is 1, and in between we have regulation. And that is, if you know data protection law, it's quite similar to that. If you are in the 4th level, then you have to report to the data protection authorities. You have to get permission. Level 2 is where you only have to document things and things like that. Now, if you know your way around data protection, there is a very similar mechanism and very similar effects there. And there's even more, which almost gets me to the end. There is another study, another project that I linked to that directly says or suggests how such an evaluation or such grading could be made. And that extremely reminded me of the criticality study. When critical data exists, if you evaluate a process, if you evaluate the effects of the use of such data on your users, and you have certain items there, you have a model which they made where you start with questions that people have to answer. You can't read this here, but these are, for example, questions about questions that checked training data for bias, which are regularly checked for biased results, and so on. It reminds me, as someone who has dealt with data protection a lot, strongly reminds me of the kind of evaluation that was made for critical data. They developed a system there to verify, to check impact, and they try to apply this to algorithms, and that means we have come a long way. We only need to get some time from Ms. von der Leyen for her to deal with these things, and I hope that she will implement this. And the German Ethics Commission made a very concrete proposal that contains concrete implementation, and in Denmark I hear something similar has been made. So there's a whole range of European states that have drafts proposals for algorithm ethics and the regulation of those, and I hope that this will lead to results. I've said that the EU, or someone said that the EU has a lot of power through its economic power, and at the same time, it has power as a regulatory power. And that's what Max Schrems said in the previous talk. The EU is in the process of exporting the GDPR. And a whole range of countries have taken over these levels. Japan is in the process of doing it. So my hope is that this will be something similar to the GDPR, that we have an algorithm ethics or regulation that we can export, and well, that something can put a stop, and that gets me to the end, and I'm glad that I was able to put these ideas to you. Great, thank you. Interesting talk. You said that people that like mangas are good programmers. We have a question from our dear participants. Why do so many people still believe in biased training? Well, that is beyond me, because I don't know, for such a long time, I talked about garbage in, garbage out, 15 years or something. Oh, no, 50. So in very young years, I have learned this, that if you put garbage into a computer, you will not get anything but garbage from it. So why people, I don't know, maybe there's a bit of politics behind it. People saying, well, this is objective, that's what the computer did. But if you know a little about how these things work, then you know garbage in, garbage out. Yeah, the computer did this. That is one of the real problems. This is a prime example. And this will lead to people saying, well, this is one analysis that yields some result. And the threat here is that people say, well, the computer said it, and the computer is a very important thing, and the decision then will then be pushed towards the computer in communication as well, because that's not the way it was thought of. It clearly says in the guidelines, it's just a recommendation, but I have to always give reasons if I diverge from the recommendation. So what does the clever employee do? They will not create extra work for themselves. They will follow the recommendation. Yeah, you said it. So this will cement our bias, our prejudice. It's women that do the care work. So we remodel reality, and it would be much better if we could work towards a better reality. We simply cast our prejudice in silicon. Yeah. The question I have is, what can we do as a society? Where should we start? But more importantly, what can the individuals out there, maybe programmers, what could they do? What should they do? Where could they contribute to making things better, and stand up and say, we need more diverse teams? Yes, that would be something. Stand up and say, we need diverse data. Say that I have a study, and people with a migration background do not appear in that study. Point to that. Or I'm conducting a study. Medical studies are mostly only conducted with men, because if you include women, you have to see which phase of their period they are in. It's much more complicated. So medical studies with men are so much more easy, and that is a huge problem, because diseases are not the same between men and women. So you have to communicate this. I teach at 2 technical universities, and I teach algorithmics, and that's exactly what I do there. And what I've talked about here is at least a 2-day course in these places. And I try to communicate how these mistakes that I've shown, mistakes in operationalization, mistakes in the choice of data, how these mistakes can be minimized. And I try to teach that to the students, both male and female. And there are not so many people by now that do algorithm ethics, but there's a lot of research, and I've linked to a number of things. There's the Bertelsmann Institute. The PDFs are all included in my slides, so you can check those. There's a weekly magazine called Algorithm Ethics. So there's a lot happening. So if you want to get into that, you can always contact me as well, and I will link you. Sicherheitskultur.at, securityculture.at. I have a number of organizations that you can work with. So there's a whole range of movements. There's one in Vienna, an organization in Vienna, a women's group about ethical use of data. There's a lot of expertise around. You've answered one of the 3 questions that we still have already. The question, how can we ensure that the right algorithms are made? But the question that links to that perhaps is there a draft for a regulation yet? Yeah, this text by the German Ethics Commission that I linked to, that could be the regulation. It has to be reformulated into this very, very long preamble format, as you know from the GDPR. The first half it starts with considering that. So the recitals. Basically, this 5-level grading. There are concrete examples that class 5 is completely prohibited, class 1 is okay, and class 2 there needs to be an impact assessment. Class 4 is where you have to have someone evaluating, some institute evaluating your procedures with external verification. Regarding whether a bias exists. So there are concrete proposals, but what I've also linked to, this huge question, this questionnaire that was concretely proposed, how algorithms could be judged or evaluated. Checking for bias, what was bias checked for, and so on. Where does the data come from? How does the algorithm itself prevent certain bias getting in? So there are very concrete things, and from other countries too. I've just taken the German language examples and some English, but there is so much. We only have to implement it. And Ms. von der Leyen intended to do that. That was one of her big programs, climate protection and algorithm ethics, regulating algorithm ethics. And there's a name for that too, UFAS. Yeah, if people try, if algorithms are developed freely, doesn't quality assurance have to begin from the start? How can it be possible? Well, yes, if the developers are educated, if they are trained to think about these things and say, is this the right algorithm that I'm using? Is it the right data? The parameters that I set for false positives and false negatives and so on, are they sensible or are they discriminating, biased? So we keep making projects that are complete nonsense. The face recognition thing at the Berlin railway station of the Südkreuz, South Cross, the small number of false positives of 1% would mean that thousands of people per day would be stopped and would have to be investigated. That simply doesn't work. And politics believes partly that that is possible, but it's completely impossible. I can't have too many false positives because then it won't work. I get too many false alarms then. So the design of the algorithm has to include all this and has to consider all this. So we need data scientists that are educated in recognizing bias and prevent bias And we need superiors that insist on this being done. There has to be enough time preserved for the development to take care of bias. And there are examples, there are methods, and it has to be done. There has to be a will, there has to be a readiness, and I hope that we will have it. Pressure has to be exerted. So we all try that. That's why we're here. It's a bottomless issue. I'm sure you'll keep coming back to that in the next few years, just as the GDPR has been keeping us busy. This is a very, very important topic that will be around. I have another question. Sorry, no, 2 questions. We'll quickly get to those. First, who is in the position to do QA for algorithms? The developers or who? Well, everyone. I have these 5 levels, these 5 classes. I've shown them. The developer that writes the algorithm can make mistakes. The next mistakes can occur by doing the use of a deep learning algorithm that isn't suited for its purpose. The next mistake can arise if I choose data as training data that is not suited for the purpose, because, for example, it contains bias if only a small part of the population is included in there. And then you have the large groups of the decision makers in politics and the upper management that would say, okay, we have an algorithm that will sort the unemployed into categories, into those that will find a new employment very easily and those that we will never find new employment for. And we have this large area, and in that large area, someone will have to find the limits. And that is nothing to do with the development of algorithms. It's about, this is a management decision and a politician's decision. And then you have the management decision that is about, do I demand an extra report from my employees, from those that process these judgments, if they diverge from the recommendation, or do I encourage them to exercise their own judgment? And if they have to justify their divergence, then that is a kind of punishment. So that is another management or ethical decision. How easy do I make it for my users to act against the recommendation of the computer? How much do I have to justify this? I know how it is in a bank. The algorithm that does the pre-check is extremely critical. The 50 plus have to go to the manager, because the algorithm, that's where the insecurity starts. Maybe this one will take early retirement. Will they ever be able to repay the credit? So it depends on how you train your employees to handle these cases. I know that in our company, it was like this. The employee that was supposed to make a judgment, the employee that meets the customer, was not going to say, the computer gives you no chance, so be careful. No, it has to be like this. The employee that makes the decision simply looks out, here's the case, and maybe doesn't even know what the computer says, because of course the decision of the computer will be an influence. And that is only one possible decision. Yes, exactly. Yes, correct. And perhaps you shouldn't even tell the people what the computer has decided. So if the computer, for example, denies credit, is the human, is the person that is going to ask questions to the customer and their gut feeling, are they still able to use that? Yeah, there's a certain critical comment. Maybe the algorithm simply models it is morally correct to want to use algorithms against bias, but is it possible? Well, these are two issues. The one thing is the intervention by Google. What I discuss with people about the question of punishment decisions or sentencing decisions where the computer decides whether someone goes to prison or not, and where the computer, in cases of doubt, puts the colored person, the black person into prison, and the European, the Caucasian white person will receive a suspended sentence. I then ask, what if in this computer or this program we would take out the factor of ethnicity? And does that mean that there is no more bias possible, but the analysis of the probability of the prediction will be less, because the bias that is embedded in the program reflects what someone reflects that whether someone has a higher probability of reoffending. Yeah, we have the fact that cliches, that prejudice helps us dealing with reality, and it helps the computer too. So in classical online marketing, people select a target group. Say I have a fitness course, and my target group is a mother, 35-year-old, Karina X, has this profession, these hobbies, takes this kind of medication. And I'm using this example because one of my customers is working in that field, and she after 3 or 4 years, she confirmed again and again, if someone comes to me for the first time, the assignment of one of 3 personas has a 99% hit rate. She doesn't need to talk much. And that is very interesting. And this is part of the problem, that this prejudice exists and is then remodeled in the digital. And that is true. And if we allow these kinds of bias or prejudice in the algorithms, if you allow these to take area of residence into account in the probability that someone is reoffending, that someone is going to reoffend, or that the probability that a credit is not going to be repaid, then yes, prediction quality is improved, but it's not fair. Now, this is you have to decide between deciding better or deciding more fairly. And I appealed in the bank that the area of residence should not be used. There are already algorithms that say if you live in this or that street, the probability of defaulting on your credit is higher. This is based on age and residence. You can say whether someone in the next half year is going to buy an SUV or something. So this is known. This has been known for 20 or 30 years, yes, but only it's now cast in silicon. It's now in the algorithm. So we solidify it, and then we suddenly believe it's not subjective anymore. There was a statement that reached us. So freedom, you cannot prove anything from the end product. You used the example early on about the algorithms that make systematic errors. So changed stop signs. We talked a lot about the bias now, but have we perhaps not thought about the fact that mistakes can also be made? And if people think, well, who's going to change a sign? I'm always thinking back to a really great talk that I have to really advertise and promote. This will be from 2013 or 2014 by David Kriesel at the Chaos Communication Congress about the Xerox copy machine, where he found that an error was made. If you use a certain product range from Xerox, numbers were changed digitally from scans that these machines made. And Xerox for a long time didn't even realize, not only did they not realize, they also denied and said that this is actually impossible, but he was right. This talk really comes highly recommended. David is a great entertainer, and that shows that if something like this happens, pardon my French, but then shit hits the fan, right? Absolutely, that is the first class of errors. The algorithm itself is wrong. That can be. And then we have the wrong choice. Whether you take this statistic or the other, you have a whole chain of probable errors, and this whole chain exists in all of these systems. And then we imagine that we have objective decision making. That is the sad thing about it. The thing that we believe that we are now objective. Philip, it was great to have you. Honestly, I could talk on for hours, and we will, but here at the Privacy Week, we'll have to stop. And we've just heard that we have a slight delay. The next talk is going to be Cory Doctorow. He has arrived, but there is a slight delay, and I'll say thank you for all the work and this really great talk. It was interesting and entertaining, and we hope that we'll hear much